A gas turbine is a rotary machine in which the chemical energy of the fuel is converted into mechanical energy or kinetic energy in terms of shaft power. In other words, it is a mechanical power or thrust delivering machine. It uses a gaseous working fluid for this purpose. The generated mechanical power can be used by industrial devices. There is a continuous flow of the working fluid in a gas turbine. Power generation gas turbines are the ones that produce shaft power. To propel an aircraft, gas turbines are used that convert fuel energy into kinetic energy for the generation of thrust. Fig. 1 below shows a typical representation of a gas turbine. Applications of a gas turbine. Major applications of gas turbines are found in as the direct and mechanical drive for various industries. Aviation, electrical power generation, oil and gas industry. Marine propulsion, turbo generators, turbo compressor. Automotive sector. Working principle of a gas turbine. The working of a gas turbine is based on the thermodynamic Brayton cycle. The Brayton cycle consists of two adiabatic work transfers and two constant pressure heat transfer heat processes. The gas undergoes an isentropic, adiabatic compression in state 1 to state 2. This process increases the temperature, pressure, and density of the gas. Next, heat is added at constant pressure in state 2 to state 3. For a gas turbine, a combustion process adds heat. During state 3 to state 4, the gas passes through an adiabatic isentropic turbine that decreases the temperature and pressure of the gas. In the case of a closed gas turbine Brayton cycle, heat is removed from the gas between state 4 and state 1 via a heat exchanger. Additional components have to be added to the gas generator to suit its application. Common to all is an air inlet but with different configurations to suit the requirements of marine use, land use or flight at speeds varying from stationary to supersonic. A propelling nozzle is added to produce thrust for flight. An extra turbine is added to drive a propeller, turboprop, or ducted fan, turbofan, to reduce fuel consumption by increasing propulsive efficiency at subsonic flight speeds. An extra turbine is also required to drive a helicopter rotor or land vehicle transmission, turboshaft, marine propeller or electrical generator, power turbine. Greater thrust to weight ratio for flight is achieved with the addition of an afterburner. The basic operation of the gas turbine is a Brayton cycle with air as the working fluid. Atmospheric air flows through the compressor that brings it to higher pressure. Energy is then added by spraying fuel into the air and igniting it so that the combustion generates a high temperature flow. This high temperature pressurized gas enters a turbine, producing a shaft work output in the process, used to drive the compressor. The unused energy comes out in the exhaust gases that can be repurposed for external work, such as directly producing thrust in a turbojet engine, or rotating a second, independent turbine, known as a power turbine, that can be connected to a fan, propeller, or electrical generator. The purpose of the gas turbine determines the design so that the most desirable split of energy between the thrust and the shaft work is achieved. The fourth step of the Brayton cycle, cooling of the working fluid, is omitted, as gas turbines are open systems that do not reuse the same air. Gas turbines are used to power aircraft, trains, ships, electrical generators, pumps, gas compressors, and tanks.